research is using science to figure out answers to wildlife management issues or conservation issues. More specifically, she's published dozens of papers on population manipulation, so she's going to talk to us about some of that today. She's published papers on using long-term data sets to try to make more informed wildlife management decisions. She's involved in conservation genetics type research. So the contributions that she's made have certainly put her in the realm of folks that have contributed as much as anybody to North American reptile and amphibian conservation. That's especially true in the Southeast. So I'm really excited to have her here, and Tracey, I'll turn it over to you.
Well, thank you all for having me. I was actually telling a couple people I went to undergrad at Furman University, and somehow I never came to Clemson, except for us to get beat in football. So anyway, I'm glad to be here today. I've seen a lot of the papers and wildlife management work coming out of Clemson. Today I'm going to talk to you about a lot of the research I've been involved in. I actually struggled with trying to pick enough things that kind of show the diversity of projects that I've really enjoyed the most without taking too long. So I might have to skip through a few slides if it drags on a little bit, but hopefully it'll be exciting. None of our work really is rocket science. It's really about answering on-the-ground research questions that managers need answers to, and sometimes kind of pushing the envelope a little bit. So I'm going to kind of give you an overview of 3 different studies. Like Kyle mentioned, there are long-term studies, and instead of going into a lot of the guts and details of the data that we've gotten back, I'm just going to give you kind of the broad brush of the things we've learned, but also talk about kind of how they arose and then where we are headed now as we continue. And the first project is about gopher tortoises, and it's a little dated, but that's what I did my dissertation on. And it's still my true love, and so I'm going to go ahead and present you that. It's kind of what set me on the path of the research that we do at the Ecology Lab. So this is really focused on what I call wild-to-wild translocation, so taking animals that are being displaced from wild populations and using them for a conservation purpose. There's been some backlash sometimes about this whole idea of moving animals from one population to another, just because it can be seen as kind of an easy solution for development, but we're kind of taking the other angle of, what can we use these animals for and help achieve a conservation purpose. And really there have been 2 study sites that have been long-term sites. The first one's on the Savannah River site, and then another is St. Catherine's Island. The study started in 1994, and I became involved in 2006. The next project is working with Blanding's turtles, and in this particular instance, we're trying to establish a new viable populations starting from head-started animals. By head-starting, I mean basically just taking hatchlings or eggs and rearing animals through their most vulnerable period. Usually we're just doing it for a year. Usually you don't use this as a method to build a new population, which I'll go into a little bit, but I'll talk about why we thought that was the best option in this particular case. And this is at the National Wildlife Refuge in Massachusetts, and we started in 2006. And finally, we have another project. It's one of the few projects that we knew from the outset was going to be a long-term study. We're going to use head starting to augment existing population of desert tortoises on the Mojave National Preserve, and we started that in 2011. And obviously working on a variety of species, I think it's becoming more and more obvious it takes a lot of partners and a lot of people on the ground, and these are kind of a collection of a lot of people that have been involved in these projects from the get-go. And I'd be remiss if I did not mention Kurt Buellman, who is my colleague on all these, and we actually are married. So I met someone that loved turtles as much as, if not more than I do, and so it's been a fun adventure. And most of you, if you know Kurt, you know he's very enthusiastic, and so that's been integral to sustaining these long-term studies. Just kind of orient you, for those of you that are more maybe used to the life history of some of the typical game species, turtles are very different, which presents its challenges. Typically they have delayed sexual maturity, so much like humans, they might reach maturity at 15 to 20 years. which leads to long generation times. Adults typically have, and really their population persistence depends on high adult survivorship, so at least 80%. Some species it can be 90 or to 95%. So if you have a situation where you're getting chronic reductions in adult survivorship, that really presents problems. And that's really an important management target, is maintaining high adult survivorship. In contrast, hatchlings and juveniles tend to have lower survival. But kind of the angle we've taken is that maybe this is an area that we can manipulate populations and help recover those that need just a little bit of help. So despite the challenges of their, what I call their slow life history, translocation and head starting has become increasingly important components of conservation for the world's most rare species of turtles. And obviously, if you're going to undertake these efforts, they're usually labor intensive, time intensive. They take a really long commitment. So you really want to have some kind of monitoring to figure out how successful it is. And eventually, you want to define success as it's eventually self-sustaining, so you're not having to continue to manipulate them. So eventually, births plus immigrations need to equal or exceed deaths and e-migrations. And so that kind of framework has led to how we've kind of approached each of our projects, where you don't want to just look at one particular metric, you need to look at all the population processes. So a lot of our projects focus on looking at site fidelity, which is more kind of a short-term measure, but then also at a longer-term perspective, looking at their survival once they're released, and also reproduction, and ultimately population viability, because that's what you're looking for. And so I'm just going to start off with gopher tortoises. And the first project I'm going to talk about is a study we did on the Savannah River site starting in 2001. And this was really focused on looking at that short-term initial metric of site fidelity. And I just want to point out that this was sort of my favorite chapter of my dissertation. But Erin Clark was a master's student on the project, and the first year of data was part of her thesis, so she had a big role to play in this project. And obviously, as I mentioned, lots of people were involved. It was pretty labor intensive. Partly, well, I'll get to that in a minute. But so for those of you who don't know what gopher tortoises are, they're this long-lived terrestrial species. Adults can take, in the southern part of the range, 10 years to mature. Here at the northeastern edge of their range, it can be 22 to 25 years. They're very charismatic. They build their own burrows. They actually have a kind of a high affinity to their burrows. Their burrows provide refuge not just for them, but also other species. So they're considered a keystone species. So over 300 species have been documented to use the burrows or the aprons. It's also important to the tortoise themselves in terms of the social structure. It's like a center of social activity. They visit each other at each other's burrows. There's like a whole soap opera going on when you're not there. And we actually think that this may be one reason that tortoises have turned out to be a species that you can translocate, is because there's such a tie to their burrow, and it's important their social dynamic, that maybe that helps contribute to their site fidelity. And also it's convenient that they make their own refugia once you move them. And like I mentioned, in some cases, when we originally started talking about doing this translocation, there was actually a lot of backlash from the tortoise community, because in the past, it had just been used as a way to get tortoises out of the way of development. No one was really doing monitoring of released animals to know how successful it was. And people viewed it as detracting from efforts to focus on land protection. Because the other conservation alternative at the time was that, well, you can just get an incidental take permit, which means it doesn't matter what happens to the tortoise at that development site, and just protect land elsewhere. But basically, because of all the permits that had been issued, we're talking about thousands of tortoises were sort of in this limbo of they were on these incidental take permits that could potentially be basically lost from the species. And so we knew it was going to be a continuing problem. And on the flip side, most of the states at this point had undergone efforts to identify all the populations on their protected areas within their states and identified which ones were not viable at their current numbers. And so they were actually ready to serve as recipient sites. And so there was an increasing need to figure out, can you actually translocate tortoises successfully, and when and how should you do it? So our goal was to repatriate gopher tortoises to the Savannah River site. It is within the historical range, but they were not present on the site at the time of when the site was established in the 50s. And the purpose of our initial project was really just to look at their site fidelity after they were released, and then also test different methods for releasing them to see if we could encourage site fidelity using the technique called pinning, which is basically we made these 1 hectare or 2.5 acre pens of drift fencing. We put in multiple animals within a single pen, and we would give them starter burrows to establish kind of an initial refugia. And people had used pinning in the past, but it was really short-term pinning, so like just a few days, maybe as long as 30 days. If you've ever trapped tortoises, you know they are much more stubborn than that, and that's a very short time frame in their life cycle. And so we wanted to try doing something more drastic and do long-term pinning. So we had 3 experimental treatments. We compared 12-month pinning, 9-month pinning, and then animals that weren't pinned at all. And these little dots are just the starter burrows that we provided as an initial refugia. And our prediction was that their site fidelity would be higher the longer you pin them. Pretty simple. And so we had an opportunity to take animals from a development site in southeast Georgia and translocate them. And this is obviously a really long way to translocate them to the northeastern part of the range where we are on the Savannah River site. And we trapped out, or if they wouldn't trap out, which it took, we trapped for probably a couple months and still some animals didn't come out, so we had to resort to digging some of them out. That's Kurt in the bottom of the burrow. And this is just a little juvenile. So that was part of the effort that took so much, was getting all these animals. We collected over 100 animals for all sizes and age classes, moved them to the Savannah River site, and we distributed them equally among the 3 different pinning treatments. And then we radio tracked the adults and subadults for the first 2 years following release. And so we did 2 different metrics of site fidelity. One was, did they stay or not? And then the other was, how big of an area did they roam? Basically, we defined a disperser as an animal that traveled more than a kilometer without establishing a burrow. You can see that with increasing pinning, we got huge differences in site fidelity. So with no pinning, only less than a third of the animals stayed in the release area. But with 12-month pinning, we only had 1 animal disperse. And so we had over 90% site fidelity. And then the other metric we looked at was their home range. And so you can see each individual is its own polygon. They're color-coded by their pinning treatment. So black is no pinning, red is 9-month, and then blue right here is the 12-month pinning. And actually the circle in the middle was the release site. So you can see a lot of them kind of fanned out from their original release site. And so both from the perspective of the proportion of animals staying and their establishing a home range was different among the release groups, and it followed our predictions that pinning was successful, and the longer you pin them, the more likely they were to stay in the release site. That really only gives you a very short-term picture of how the population does after you release them, and so we wanted to look at sort of a longer-term metric. And I had the opportunity to work with Terry Norton, who was a wildlife veterinarian on St. Catherine's Island, which is this privately owned island that originally the Bronx Zoo and Wildlife Conservation Society used as a place to keep and breed animals that were hard to breed in a zoo setting. But they had also agreed to serve as the first recipient site for translocated gopher tortoises in Georgia. And they were more interested, being veterinarians, they were interested in the health perspectives. They had done a bunch of trapping to monitor their health over time. But we took advantage of the Recapture records to estimate survival. And when I became involved in 2006, we tried to do a roundup of all the turtles that were still remaining on the site. And basically, the gist of what we found is it was kind of an interesting situation. So the big translocation of tortoises that was sanctioned by Georgia's DNR happened in 1994, and that was about 74 animals. But apparently, someone that worked on the island had been surreptitiously releasing tortoises from random locations, and we estimate there were probably about 25 or 35 of those animals. So we got unmarked animals that we got recorded in our capture efforts. So here's kind of our capture intervals, and I have 2 groups. the blue ones were the previously established, the ones that were surreptitiously and without permission released on the island. And then this newly released group were the ones that were purposely translocated as part of a big translocation project. And really the big things you can see is the animals that were newly released, there was kind of a dip in survival, and that's probably it corresponds to what we saw with our telemetry studies. They're probably just dispersing from the area, it's not actually mortality associated with the translocation. But shortly after their release, within a year, all of the animals had 98% annual survivorship, which is, even for a long-lived turtle that you expect higher survival, that is awesome survival. So we had really optimistic results from that study. And there was one other study that had done something similar in Florida. They had less capture intervals, but they saw pretty similar patterns. Basically a dip in apparent survival right after their release, but once they're established, really high survival each of the subsequent years. And at the time, there wasn't really any natural or data from naturally occurring populations to say, well, how does what we see compare to what's in wild populations? Well, the data weren't there. But fortunately, someone on my committee had mark recapture data that he was willing to share, and we actually analyzed the mark recapture data for 3 populations in South Georgia and Alabama, and found pretty much the same pattern as high adult survivorship. Ours was as high as anything they reported, and it was constant over time. So we felt pretty good about, once the animal's established, there's pretty good prospects for that population. And then also at St. Catherine's, because we were capturing all these individuals, we took advantage of having our hands on them and collected blood samples from all the potential adult breeders. Then we collected nests during 2006 and 2007 and tried to assign parentage, so assign mom and dad to each of the offspring. And this ended up, I always call them as having kind of like a soap opera. So we've done studies where we've monitored them with the camera, see who's visiting who. This is another way to learn about their secret lives, is assigning parentage. And so you can see all the candidate males are on the bottom. You can see a lot of them are actually not successful, or at least they didn't have offspring represented in our sample. There's a lot of variation among the males and how successful they are. And these 3 most successful males are all animals that had been previously established on the island before the big translocation happened. So to me that was fascinating, because even the newly released animals had been on the island for over 10 years. And so we're still seeing that effect of initial residence in terms of their reproductive success. It was even more striking given that they're just how the ratio of previously established and newly released animals. So there's only a few males that had been released on the island prior to the big translocation, yet they represented or fathered over 60% of the offspring. So that was actually a potential area of concern, that maybe not all the newly released males are being integrated into the population. Similar things have now been seen with desert tortoises that have been translocated. But actually I had a student do a similar parentage study in naturally occurring populations, and they're seeing the same things. There's a lot of promiscuity, there's males and females mating with both mates, and also a lot of reproductive skew among the males in the population. So it's not necessarily an artifact of translocation, that just happens in naturally occurring populations. So basically some of the things that we learned from doing these translocation studies was, 1, we felt very optimistic that you could actually successfully use translocation to establish viable populations of tortoises. We're actually heartened to see that the telemetry data corresponded really well with the long-term metric of survival. And one of the things that really struck me and has kind of affected the rest of the stuff that we do is because we took an experimental approach and to compare different release treatments, and because it proved to be so successful and we could quantify that success, it resulted in management agencies adopting that as their protocol when they do translocations. So that really made an impression on me. And also the other thing I like to think about now is, I know we tend to be conservative about what we are willing to do, how much manipulations we're willing to undertake, and I think sometimes it's good to remember that it's important to maybe do some of these manipulations while things are still in a common enough that if you don't get it right the first time, then you have a little bit of wiggle room to try to make it work the next time. So the next project I'm going to talk about is Blanding's turtle. And as I mentioned, we used head starting to try to establish a new population of Blanding's turtles. I'm probably going to say tortoises, because I'm used to talking about tortoises all the time. Just to get you an idea of linking head starting to turtle recovery is, as I mentioned, their life history of turtles in general is that hatchling survivorship is really low. And so it's rare that if you're trying to recover a population, then that in itself is going to be the one thing that you can use. You really need to ensure adult survivorship. But maybe because it's so low, naturally, is maybe that's a target you can actually tweak. And sometimes it doesn't take very much tweaking to actually change a population from declining to increasing. And we're sort of taking the perspective of this is not something you want to do long term as a way that you have to permanently maintain a population, but maybe just give the population a boost until it gets to the point where it's self-sustaining. And just to give you a perspective on Blanding's turtles, they're pretty wide-ranging, but I'm going to focus on these populations in the northeast. But actually, the data we used to build the PDA came from populations from the farther range. And this is really, to me, a story about opportunity. There was this site in Massachusetts. First of all, where it occurred is it's disjunct from the main part of the range. It's a species of concern in each state that occurs in New England. Only 9 sites have at least 10 to 50 animals. And there are only 2 to 3 sites with really big populations of at least 50 individuals. So that's why our goal was to just start from scratch and build a new population. But we had this opportunity to work at Assabet River National Wildlife Refuge. There was no known resident population. There had been a roadkill observed nearby, but there had been a lot of trapping. Actually, that's how we got involved in the project. Is Kurt got a grant from NIFWIF to evaluate several different national wildlife refuges and their suitability and how viable their different turtle populations were. And this was one of the sites that he looked at, and he trapped extensively, and there was no record and no documentation of Blanding's turtles. Yet it was a 1 square kilometer just west of Boston, where it's entirely surrounded by development, had a variety of wetland habitats, and that's one thing that Blanding's turtle needs. They use a variety of different wetland habitats. They're kind of wide-ranging in terms of their daily activity patterns. And the reason we think they weren't there currently is it used to be a cranberry operation, and then it was an army depot. So site history had probably affected site occupancy by Blanding's turtles, but now it had been turned into a refuge with a pretty sizable area. And the nearest viable population was over 16 kilometers away, so it's obviously not going to get colonized by that population, and it was separated by a lot of development. And the other side of the opportunity equation was the donor site, which I'm not going to name because we've had poaching there. But it is a site that was also owned by Fish and Wildlife Service, occurs in the same river drainage, so theoretically you're not worried about genetics. Is that something that you worry about? It's the most robust population in the state, and there was also a biological consultant that had done his master's research on Blanding's turtle there and cared so much about the population, he'd been nest protecting there since 1987. So he'd been artificially boosting the recruitment in that population for a long time. And so before we got started, we actually it took a lot of convincing to get everybody on board. Fortunately, the wildlife biologist at the refuge was very excited about it. But even though that site was owned by Fish and Wildlife Service and the species isn't listed, we still had to go through an EA, so an environmental assessment. And not everybody was on board. They thought it would detract from efforts to protect land. But at the time, there weren't any places with known populations, and they were spending millions of dollars to protect small pieces of land where there were isolated records. So we're like, this is way cheaper. And so we had to go kind of through this process of convincing them. Some of the different things we talked about were what were the impacts to the donor site, and what's the appropriate life stage, and also have we done any population modeling. And these are kind of the ones I want to focus on. obviously we picked the donor site because we felt pretty good that it's been artificially boosted for a long time in terms of recruitment into the population. And the reason we decided that it's not appropriate to do adults, even though it takes a long time to see any success by just releasing hatchlings and head starts, each adult is so valuable and they're so viable populations, we just didn't really even want to go there. So we're like, well, let's just see if we can start this one from scratch, from release hatchlings and head starts. And then, so the Fish and Wildlife Service wanted some kind of guidance on, like, how many should we release, and how long should we do the releases, and when can we expect to see an effect? And so we attempted to build a PVA, and we used data from a long-term study in Michigan by Conda, and these are the parameters. I'm not going to go into them, but it's basically same things you expect: long-lived, takes a long time to reproduce. Once they do reproduce, he has adult females that are over 60 years old that still come out and breed. Nest survivorship is highly variable, and again, that survival during the first year is really low, so less than 26%. And so, obviously, we don't know what's going to happen with the individual population that we were working with at the site where we planned to work, and we were kind of making ballpark guess about what was going to happen in terms of, how well would Head Starts fare versus direct release hatchlings, but we tried to come up with some initial scenarios that we thought were reasonable to undertake. So we modeled releasing 25 hatchlings, 15 hatchlings to 100. It was kind of what we thought our max capability was at the time. And actually 100 was probably pretty optimistic about what we could do. Or, should we put our efforts into Head Starts? And it was clear, assuming, Head Starts weren't at a disadvantage, that it would be better off putting our eggs towards head starting. And so that's kind of the route we took, but we also wanted to quantify again the effect of our manipulation. So we wanted an experimental approach, and we also didn't want to negatively impact the donor population. So our strategy was to collect nests at the donor sites, and we had to, from each female's clutch, we tried to divide the eggs such that 50% or half got released back at the donor site, and then of the remaining hatchlings, they got split between the two treatments. Half were head started for a year, actually 9 months, and the other half were directly released into the wetland. And the other reason I want to talk about this project, because I think it's really cool, just the partners that we ended up partnering with. So initially, the first couple years, the refuge staff were all raising turtles in an aquarium in their offices or at their house, so we had really limited capability and maybe expertise to do it. But in 2011, a high school approached the refuge about being the Head Start facility, and it's kind of a different school it's kind of like the governor's equivalent. But it was a school that was focused on natural resource management. The students had to apply and compete to be a student at that school, and different grades focused on different things. And it was a sophomore class that was in charge of the Blandings turtles. And it's perfect timing because the eggs hatch, the hatchlings arrive at the beginning of the school year, they raise them all year long, and they're ready to be released at the end of the school year. And the entire year, they're responsible for their care. They take data on them every week, which they post to a Google Doc that all the partners can see. They have a dedicated greenhouse. It was just really phenomenal. And if you think of, they also are the students are in charge of the project, or at least in terms of the husbandry. Like, I went to visit a couple of times, and they have a biosecurity protocol. They're responsible for enforcing it, and they did. They made sure, the rest of us knew what we're supposed to be doing. But the really cool part was, at the end of the head starting period, the last kind of hurrah for their class was they went out to the refuge and got to help release all the turtles. And actually, one of the students that was an intern at a student at the high school that participated in this project, she's now an intern at the Fish and Wildlife Service Refuge. So I think it's just a cool story from that perspective. So we knew that we were successful in terms of boosting the size of the animals after head starting. So the head starts, that's what HS is, direct release of the same cohort, is DR. So they're about twice the size after being head started as when they hatch, and it ends up being about the equivalent size of a 3 to 4 year old. But we really didn't know what happened to them after we released them. And so this is kind of just a tally of what we had released up through 2011. We tried to equally split it between head starts and direct release. It didn't always go according to plan, but we wanted some kind of at least initial assessment of how successful it was. And so a couple of years, interns for the summer went out and trapped the release site to try to capture some of the released animals. And just in this very kind of cursory trapping effort, they're already seeing that, they're picking up a lot more head starts than direct releases. Still not many, because it was a pretty limited trapping effort, because they had a lot of other responsibilities. And if you actually saw the habitat, you can see it's actually very challenging to navigate and trap, and so it takes a long time to check traps. But we had the opportunity, actually one of the interns that trapped those 2 years, he actually came to work for us as a graduate student because we got funding from Disney to actually follow up and really assess how well the head starts were doing compared to the direct release hatchlings. And he graduated in 2015, and the data I'm going to present are from his thesis. So just to reorient you, the releases done from 2007 to 2014. There was trapping, sort of low-level trapping effort in 2011 and 12, and then he did some intensive work in 13 and 14. And just to give you an idea of how many are released, so our capacity went up over time, and this is when the high school joined, so it really boosted our capacity for releasing animals. This is just a quick look, and so orange are the ones that weren't captured, and blue are the ones that were recaptured. So, we're not seeing everybody, but we're seeing a pretty good proportion, and we're seeing a whole lot more of the head starts than the direct releases. One of the issues that we had to, that kind of really affects what we can say about our recaptures is that there's a minimum size to really be effectively captured in the traps. And so anything really below 40, 45 millimeters isn't trappable. And so we wanted to limit our analysis to, we eliminated the 2 more recent years, so they probably weren't big enough for us to actually effectively sample. And then we did not include this year because our sample size was so small. But basically what he found was there was an incredible difference in post-release survival. It's really that first year after you release them that makes the difference. But the head starts had survival 6 times that of the direct releases. And so we're feeling really good about, at least we're making a positive effect. It's still going to take a long time to get a viable population. But given that animals when we release are about the size of 3 or 4 year olds, and actually head starting might reduce the time needed to reach maturity, they're kind of thinking ahead and building nesting areas so that when that happens and that magic moment happens, that we'll be ready for them. And then also they've actually just recontacted us again, and so they want to kind of reevaluate the PVA. Now that we have actual data from our study site, we know how well head starts are doing compared to direct releases. We're going to reevaluate kind of our release scenario and try to figure out how long is it that we need to continue doing this to get kind of our target population size. Again, we had lots of collaborators and supporters. And one of the take-home messages for me, really, from this project was, it really came down to some key people. Like, this project would not have happened if these 3 people weren't involved. Stephanie was the wildlife biologist at the refuge that got really excited about the idea. She championed against the Regional Fish and Wildlife Service Office, the state agencies, and she supervises all the interns that work on the project. So that really wouldn't have happened without that catalyst. Brian Butler is the biological consultant that had been nest protecting for 20 years at the donor site, and he's also volunteered a lot of his time and his staff's time to come help on the project. And Brian Bostarach is the high school teacher that kind of reached out to Stephanie and got his students involved, and it's really been incredible. So with that, I'm just going to move on to my last project, which, again, it's head starting. This time we're not trying to start from scratch, which is a good thing because it's a lot more challenging, we found, with desert tortoises than with blandings. And again, this project, taking place in the Mojave National Preserve, And so the desert tortoise is federally threatened, and there's a lot of reasons for the decline. So the typical suspects, and in this part of the range, there's actually the added things of a lot of the military bases have heavy training activities, and so there's been a lot of displacement of animals due to that. And then also we're having a lot of solar development in the area, and so it's having big impacts on even what we used to consider viable populations. And the other thing is, it's been listed for quite a long time. There's been millions and millions of dollars spent on desert tortoises, and we still don't know a lot about them. And so, especially when you think about the juveniles, there's very little known about them. And so, one, they have a lot of issues. We're trying to figure out different ways to recover them, and we're kind of working in a black box, so we don't know what normal is for juveniles in some cases. You just don't see them that often. I mean, we're talking about these big, vast landscapes. They're very cryptic, and they don't spend a lot of time above ground. They don't always make their own burrows. They use a lot of existing tunnels, so it's even hard to detect their burrows. And so really, most of what we know about desert tortoises is based on adults. But we got involved in this project because it's actually kind of an interesting background. So within the Mojave National Preserve, Chevron had a pipeline that experienced a leak, and as part of, actually it wasn't Chevron, it was Molycorp. As part of mitigation, they wanted to figure out, what is something good that can come from this mitigation dollars. And actually Chevron bought out Molycorp and took over the kind of environmental responsibility. And so they worked with Fish and Wildlife Service, BLM, Park Service to really identify what's the best thing that we can do with this mitigation money. And what they wanted to do was actually provide the opportunity to do from the beginning what they considered to be a long-term project to really investigate whether or not head starting could contribute to population recovery. And so they advertised for someone to submit proposals to investigate head starting. They built a research facility that was to be used solely for head starting, and they wanted it to be a 15-year length project with the idea is that that's what it takes to be reached from hatchling to age at maturity. Now, it's not enough money to run the whole operation for 15 years, but it was supposed to be seed money to kind of stimulate the project. And so we got involved in 2011 on this project, and up at that point, no one really knew how useful head starting might be as a recovery tool. There had been some attempts to investigate it, especially on the military installations in the western Mojave, and their focus is different. Whereas we're rearing the Blandings turtles indoors, these animals, the desert tortoise, they've always done outdoors, so they want it to be as natural as possible. And so, but that also means they undergo dormancy. And so they become inactive for the entire winter. So they're not growing. So they're losing kind of lost opportunity for growth. But from these outdoor rearing facilities, they've learned a few different things. One, they could do it successfully. When they provide supplemental rain, that actually boosts their growth. When they've released animals, there's very variable survival, but generally the bigger you release them, the better off you are. But based on sort of what survives when they release and what doesn't, they came up with a recommended release size of about 84 to 120 millimeters, which desert tortoises grow really slow, and that's about 5 to 9 years of head starting. And so it's a very labor-intensive undertaking. And so one of our goals was to try to tweak it so it takes less time to do that. So again, these are our partners. Most of our funding came through the Park Service, through the mitigation funding, but we've also received money from BLM and California Energy Commission. And our study sites in Southern California in the Mojave Desert. And so our basic way we operate is that we radio track females. They're basically our egg donors that we kind of track just enough to keep tabs on. X-ray them in the field. If they're gravid, they come into our outdoor enclosures. This is the other piece that Chevron provided in addition to the research facility, those outdoor enclosures. Allow them to nest, release them back into the habitat, and this is the habitat when it looks really good and it's gotten a lot of rain. It's really beautiful. And then we assign the hatchlings to their head starting treatments. And the theme of this one is, we haven't cracked this nut yet. We're trying different things, and I'm just going to talk about the different phases where we are. So this is my iterative process. So if it doesn't work the first time, you got to keep figuring out how to tweak the system. So we learned from these previous projects that other people have done that it takes a long time to get a head start of releasable size. We didn't want to wait that long to do any releases because it's a lot of capital investment, and you don't want to get it wrong by the time you've invested 7 years in head starting an animal. So we actually did some pilot releases of smaller animals just to get an idea of what are the habitats that they're using, what can we expect in terms of how far they're going to go, basic things like that, while we're basically stockpiling animals in our head start pens. And so we did just pretty small sample size, because we were trying to stockpile as many as possible. So we released a total of 46 animals over 3 different release periods. And the idea was, even though there had been some releases of these smaller sizes in other parts of the desert, this is a new part of their range, so we wanted to get baseline data for that. They also did not release hatchlings as a control, and we wanted that experimental control. And we wanted to be able to learn something about the habitats they're choosing in our study system so that we could do our future releases better. And the other reason we released some is we were running out of room in our pens, and we wanted to keep adding more head starts to our pens. So basically some of the things that we learned were they do great in the pens. They get 94% survival because there's netting to protect from birds. There's fencing to protect from mammals. They're getting supplemental rain. So, life is good inside the pens. The higher survival was associated with higher hatch size. Size at release didn't really seem to matter, which I'm going to go into later. But once they're released into the field, about half of them survive each year. And in our particular cases, during the early releases, most of the mortalities were due to exposure rather than predation. And one of the reasons size is an advantage, the bigger you are, the more water you can store to make it through the dry periods. And so we think that's one of the contributors to the effects of size on release success. But in our case, it was desiccation or exposure, not predation, at least in the early phase. We also learned a little bit about the types of places they like to choose and where they fare well, so we're going to use that in our future releases. And in the meantime, we're kind of waiting for our animals to get big enough so that we can release the recommended size animals for release. We were able to take on also a graduate student to really tackle this question of, can you use indoor head starting to increase their growth, boost their survival after release, and really cut down on the duration of head starting. So he did the 2015 cohort. He had a pretty good sample size. We did 3 treatments. So we did direct release, so just putting naive hatchlings out into the habitat. We did the standard outdoor rearing, and then we added the new treatment of indoor rearing. So just to give you an idea of the size difference, so this is outdoor head starting for 9 months. Basically, they're like a millimeter or 2 longer than the wild release, directly release animals because they're getting a little supplemental rain, but this is the indoor head starting. So we're really optimistic. We're like, this is going to be great. They're going to survive awesome out there. So he picked a release area, and we kind of evenly distributed them and randomly amongst each other in one big release block. Some animals, like the direct releases, were released in the fall right after they hatched, and the head starts from both different treatments released the following spring. And we did not see a difference in survival, which was disheartening. And I'm going to explain to you why. Because right after our spring release, so as soon as we released all the animals, a raven set up a nest right near our release site, and they just picked off our animals left and right. So the greatest risk to our animals changed between our first releases and our second releases. We didn't have a raven problem initially. Now we do. We did learn that maybe we'll release in the fall after all the nestlings have left and they're not trying to feed baby tortoises to their nestlings. But really one of the big striking things was what was the big differences in the fate of the animals from the different treatment groups. And the big thing that really stuck out was that we had a lot of bird predations on the indoor head-started animals. We got them in all the groups. They really stuck out in terms of indoor animals. But we really didn't get exposure in the red as being a big contributor to the indoors, which actually to us was promising because, they're naive animals. They've never burrowed. They've been inside all their lives, fed a la carte. And so that wasn't a problem for them. It was the birds. And we tried to figure out why. We did see differences in how far animals would disperse initially after they were released. And one thing to kind of keep in mind that's sort of a different experience of the different groups is direct release hatchlings were naive hatchlings, never burrowed, just like they would in the wild, just thrown out there to fend on their own. Indoor head starts also had never burrowed because they couldn't do that indoors, and they didn't have any natural cues during their entire husbandry period. Outdoor animals kind of did the normal wild thing. They were just protected from predators. And it kind of sticks out that they behaved a little bit differently. So they didn't go as far as the other two treatments. We didn't really see a difference in how often different animals from the different groups were active on the surface. So it's not like all the indoors were being stupid and standing on the surface and not being in a burrow. And when they were out, it wasn't like they were less or more likely to be undercover or not. One thing that did stand out was we compared how abundant the tortoise-sized rocks were in the areas that tortoises use. And the tortoise-sized rocks varied between the different treatment groups. And so the smaller animals, the direct release and the outdoor animals, all the rocks were the same size of them. As the indoor animals, they needed much bigger rocks to be better camouflaged, and they were not common in our release area. And so for an aerial predator, they were very conspicuous. So that's what we're thinking is the reason. We also looked at a variety of factors to try to see what would predict their fate, whether they lived or died. And we looked at release size, experimental treatment, all the things we were hoping to see as a factor. And the big thing was how far they were from a raven nest when they were released. And we determined that you need to be about twice as far as we originally thought from a power line or roost structure. As originally people were saying, you need to be 750 meters, a kilometer away. It's not until you get 1.6 kilometers away that your probability of getting picked off by a raven really drops off. So we're going to factor that into our future releases. So basically the take-home message were indoor head storing does increase growth, but it didn't really help us with survival. But we also, the highest source of mortality changed from one release to the next, which is only a couple years apart. And then it really is important where you release them. So we did learn, things that we need to consider when we're doing our next releases. What is the cobble structure and how camouflaged animals will be, and then also how far from the roosting structures we need to be. And I'll wrap this up really quickly. So the next phase, we have a new student we just brought on. We're finally getting some of the original questions we wanted to ask. So he's going to be doing what we call hybrid rearing. We're going to do indoor rearing for a year where you get that growth and size on them, get them outdoors for the second year, so maybe they learn to be a tortoise before we actually release them. And then we finally have enough animals stockpiled, so we're also just going to release a bunch of animals sort of across a wide range of size classes that all meet the minimum recommended size threshold. And this was sort of what the whole grant was written about, but it's taken us since 2011 to get here. And again, we're just trying to get back to this I think it's kind of a vicious cycle. We're still going through okay, what did we learn from the last one? Let's try to tweak it in this, and we're hoping we'll have better news the next time I talk about this. And we're really just at the beginning. This has been sort of one of the more challenging projects where success is not as obvious, and I think it's going to take a lot of tweaking. And so I think the important thing is just not give up, and it's another reason to do things while things are still common, because we can take some time to tweak things and hopefully eventually get it to work. But this whole all these projects I think kind of illustrate the way that we think, we should start thinking about reintroduction success is, it's really about getting viable populations. You need to look at multiple processes. It takes a long time to really determine whether or not you're having any success. If you use an experimental approach, you can quantify your success. One of the things I think we often ignore and we still haven't been able to address is you need replication in multiple study sites to see how applicable what you learned at your site is broadly applicable to others. And I think the part that is the most fun is that each project has different challenges, so you have to come up with different strategies. So it's not cookbook. So that, I guess that'll keep us in business. And that's the end, so we have an update. Thank you. Questions in the back?
Yeah, what is the big difference between indoor and outdoor? Do you think it's just exposure, or does it have to do with their diet, what you're feeding them? Do you feed them anything in the outdoor pens?
Well, originally, so they obviously get fed indoors, and originally we did not feed outdoors, at least in the early head starting. But if you can imagine, they're in a pretty confined space. You know, they're in the pens for years. We do now feed the pens each year, and then also add supplemental food. But in that one experiment where the students did the 3 different techniques, they also got, throughout the study, they got their same groceries that basically the indoor animals got. They had native forage, but they also had access to supplemental food that we provided. Any other questions?
Is there anything about the first study that you talked about with the gopher tortoises, is there anything about the low density of animals on, I think it was St. Catherine's, that the ones that were there previous to when you guys established the population? You said there were already some animals there, right? Mm-hmm. Is there anything about the low density that maybe contributed to their reproductive success in terms of resource acquisition or something, or do you think it was just the time that they were on the island?
I think it's the residency time because the new animals got released into the same area, so everyone had to be kind of integrated. It's not your typical habitat, it's actually mowed pasture, but it's incredibly productive. Like I had a student look at growth rates in juveniles. It's the highest that's been recorded anywhere. I mean, South Florida is the only place that has similar growth rates. So they're growing and getting enough resources. I think it's all the social part. They have a pretty interesting social dynamic. Apparently, some of Craig Garner's work was they have social cliques where some tortoises like to interact and some don't like to interact, and there's not much crossover. And so I think that has a lot to do with it. And one thing that people are worried about translocation is if you disrupt that social structure, and obviously if you're augmenting populations, that's something to consider. And there was a study with desert tortoises where they're doing translocating lots of animals on Fort Irwin, and they didn't get any of the translocated males to reproduce. Only the resident males were reproducing. Now that might change over time. And actually, so I mentioned that we had both males and females of residents mating with the new animals. The interesting thing was the females didn't take any time to get integrated into the population. We got crosses with newly released females with previously established males. Recaptures introduced. It's just the males that have the problem. There's a lot of jockeying for position.
In less manipulated systems, do you see dominant males? I mean, I would imagine proportions are different, but there probably is some dominance and some other males that are breeding less.
I had a master's student, she just finished. She worked at Archbold Biological Station with Betsy Rothenrail and Kelly Zamudio, and we were really interested in the system because it's a long-term study system where Jim Lane had been working with animals 50 years ago. So we're actually hoping that we would actually know a lot more of the history of the animals and how old they were and whether male age contributed to your success. But she put cameras at the adult female burrows, and if you paint their numbers on their cells, you can see who's visiting each other. She saw huge reproductive skew. I mean, the graph almost looked the same, except she had different numbers of males in her breeding pools. A lot of males missing out on opportunities. The males on the fringe, it seems like some of the smaller males or less dominant males get pushed to the fringe, and they don't get as much opportunity to visit females. But hers were concentrated in a really small area, high density population, and same thing. Even though males could obviously visit all the females in the population, it was only a few that were successful. And so that actually makes me feel a little bit better because it's, we're seeing some of the same things in natural populations. Yes.
So what are you seeing in terms of movement patterns in the desert tortoise study between, animals subject to those different rearing treatments? Do they have different movement patterns, home range, dispersal patterns?
Well, so desert tortoises move a lot more than gopher tortoises. I did learn that. So like the adults can move like a kilometer in a day sometimes. They don't always, but you know, sometimes you get a surprise when you go out there. If I remember from the initial releases, we got the most dispersal. It's hard to call it home range because they don't necessarily go back and reuse same burrows the same that gopher tortoises do. So there's a lot of like linear movements. But the hatchlings actually disperse more than the older animals, whether they were 6 months, 12 months, or 18 months. And then I don't have the numbers for the indoor versus the outdoor, but it did seem that the outdoor ones seemed to establish a burrow quicker once they were released. And the only thing we could think of that made sense for all the different comparison was that they had just done it before. They're the only ones that actually built a burrow, kind of had all the natural cues, and those naive hatchlings are just running around trying to figure out what's going on. And then indoor animals, you know, I think they're a little shell shocked when you first release them. That's the main differences. Anyone else?
Just a couple of quick announcements. One, if you're in my wetlands class, there's a sign-up sheet right outside the door. Two, if you're thirsty, we're going to go to Nick's, so you're welcome to join us. We'll be in there. We'll wrap up here. So let's thank Tracey one time.
most.
It would only change by a
But
little.
here, because it's straight in, like, I mean, there's spots where I can look at the rock. And
Not that I'm a great
because the way that it's like, water is gonna make its way. I don't know, there's just. I think it's like wild. It's pretty terrible. The one state agency was still selling for leasing minerals. Obviously they have to lease access to the roads. It's like $320 million. And that money was like, put enough basically in the contract. So these leases. So like, areas are like, okay about, the rest else, all that, and like, just put it back. Yeah, it's like $40 million. Like, and these leases, it's just total. And the real goal was, when we said it's reproduction is going on this trout, it's like, no, we want to be able to classify as a trout, so that we've got some buffers.
Well-paid.
Is fracking.
So they're not gonna,
It's just.
your car,
Good luck.